Physics, Chapter 17, Word Problems. Now, I'm going to give you a copy of this in the assignment so you can work along with me. And we're just going to work through them so you can become familiar with them. Now, before we do, let me show you some formulas. The first one is, we'll do some easier ones first. Pressure equals force over area. And typically force is newtons. Well, it is newtons. And area, meters squared. Then we've got density. Mass over volume. Normally, it is kilogram times meter cubed. A formula that's more common sense than actually working it is the area and the velocities of a particular space. And you'll see those when we get to them. This one I mentioned in the videos. P sub H is pressure at a certain height or depth. P sub O is atmospheric pressure or surface pressure. Rho, which I know you like, looks like a P. Well, it's actually rho, but density. G is, of course, gravity. H is height or depth. And then last but not least, buoyant force, rho G V, or density, gravity, volume. So the formulas themselves are not hard to deal with. The units are also not hard to deal with. Buoyant force, of course, in newtons. Pressure, Newton per meter squared. So, let's get busy. Now, this first one is one of the easier types. You've got area and you've got velocity. So this one is the one that all you have to do is area times velocity or speed equals area, which is what you're looking for, times the speed. So 0.15 times 8 equals 21 times A for area. Multiply those, divide by 21, hopefully, 0.06 meters squared. There's another one on the worksheet that is actually super similar. We can skip down to it. Number 5, fluid flows through the tube at a speed, area. How fast will it flow when the area is this? Now, on this type of problem, since all you're doing is multiplying and dividing, you're not using any derived units, you actually do not have to convert those because they're actually going to cancel out. Because if you did 12 meters per second times 9 equals 20 V for velocity, you would actually divide it out here so they would cancel. So when you divide by 20, you should get 5.4 meters per second. Now let's go back up to 2, that type. A piston has an area, pressure, force. So pressure equals force over area. So pressure, 85. Force, what we're looking for, area, 24. Cross multiply, 2,040 newtons. 3 is also a similar one. We've got force, dimensions of the object, or the piston, and pressure is what we're looking for. So pressure equals force over area. Well, they give us the dimensions. And notice how dimensions are supposed to be Newton per meter squared. So you can just change 2 to the right. So 0.09, 0.02, so 0.0018. And you should get 31,111 Newton per meter squared. All right. Well, this one, number 4, is kind of obvious which one it is, because they give us pressure below the surface, then they give us density, then they give us atmospheric pressure. So give us 2 different pressures. We know it's got to be that one. So pressure at a certain height or depth, 2.4 times 10 to the 5th, equals atmospheric or surface pressure plus PG H, height or depth. So on this, subtract that over, divide by those 2. Hopefully you get 6.1 meters. The other one that's like this is number 7. The density of seawater. Pressure at the top of the ocean. So top is same thing as surface or atmospheric. Find the pressure that far below sea level. Well, that's what we're looking for. P sub H. Surface pressure, 101,325, plus density, gravity, height, 1450. Multiply all 3 of those, add 101,000, and you should get a rather large number. 14,737,625 Newton per meter squared. So far the math in this chapter, very straightforward. I saved buoyant force for last because sometimes the units make it a little persnickety. The formula itself is not bad, but when you plug in, you've got to be careful with the units. Because notice how it's grams per centimeter cubed. So that just makes it a little sticky. Now we'll do this one first. We'll go to 8. What is the buoyant force of, and that gives us the dimensions in centimeter, brick that has a density of that? Well, buoyant force equals rho GV. So buoyant force equals density. I'm going to put the units on this one so you see what's going on. G, 9.8. That one, I won't make you worry about the units because they're going to take care of itself. And then volume, 4 times 6 times 13. Hopefully you get 312 centimeters cubed. Now you can see why I left that in there. Centimeters cubed cancel. So when you multiply all of those, it's going to give you grams. Well, remember the derived unit for Newton involves kilograms. So that's going to be a problem. So last but not least, when you multiply, to change grams to kilograms, think 3 to the left. So that is actually 1, 2, 3. So instead of multiplying 2.5 by 9.8312, you're going to multiply 0.0025 times 9.8 times 312. About 7.6 newtons. So notice how if you leave the units in, centimeter cubed, but your volume is centimeters cubed, so it cancels. So the only thing you have to convert is grams to kilograms by moving it 3 to the left. And then you're good. Now 6 is a little bit weirder. Now they give you buoyant force, so I know you're like, whoo-hoo. One more zero. Equals density of lead, so 11.3 grams centimeter cubed. 9.8. Volume, what we're looking for. So those units are good. We've got newtons. We've got that one. As far as the derived unit for Newton, kilogram times meter over second squared. So all that's going to take care of itself. Here is the problem. We need that in kilograms and in meters. Well, here's what you can do over to the side. I have room, I'll do it down here. 11.3 grams per centimeter cubed. Well, what I would do first is grams to get it out of the way. 1,000 grams in a kilogram. So now I got kilograms. Now I need meters cubed. Centimeters on bottom, centimeters on top. But since it's cubed, it's cubed. So notice how that's 100 cubed, or 100,000, or in other words, 6 zeros on top, divided by 1,000, 3 zeros. So that is the same thing, if you want to convert, is multiplying it by 1,000. Believe it or not. So that, if you multiply it by 1,000, 1, 2, 3. So that times 9.8 divided into this, and you should get 4.9 meters cubed, because the other units will take care of itself. So the shortcut that'll work every single time, if you're trying to do grams per centimeter cubed to kilogram per meters cubed, since 1,000 grams are in a kilogram, 100 centimeters are in a meter, and you're going to cube it, so that's why I got 6 zeros over 1,000. So that will always be just times 1,000. Not too bad. Not fun, but not too bad. The easier type is if they give you buoyant force and it's in centimeters, because then all you have to do is move it 3 to the left to go from gram to kilogram. The other math is very straightforward. Hope this is going to be a good test for you in a couple of weeks. The math is straightforward, quite a bit of vocab, but that's on the videos. Hope you have a great day. As normal, any questions, let me know.